Uh, Good morning, good afternoon, good night, good evening, wherever you are seeing us. Uh, this is we are students from the State Polytechnic of Malang, mechanical engineering students, and the study program is mechanical production and maintenance engineering. We are semester five students. This is a presentation that was given to us in under the course advanced machining techniques that is being delivered to us by our lecturer, Pak Muzaki. The topic that we are going to present about today is electrical discharge machining. And before we go ahead, I would like to introduce all the members of this group. I'll start by myself. My name is Ajang Deng Biowei.
And my name is Adesta Dermaawan Wicaksono.
My name is Ahmad Zulfa from Malisi.
All right, we shall get right into the presentation. So let's start. Right. And the most important thing is to first know what you are talking about or what you are going to be learning about, which is why everything has to be defined before it's discussed more. So the definition of our topic today, which is electrical discharge machine, in other words, it can be called EDM. So electrical discharge machine is a non-conventional machine tool in which the process of cutting material, or in other words, material removal from the workpieces in the form of erosion, which occurs due to the presence of a number of periodic electrical sparks in the gap between the cathode, which we can call the chisel, and the anode, which is the workpiece, inside the electric fluid. In simple terms, EDM is a series of fast intermediate curves, two electrodes as a cutting tool, and the working pad in front, energetic electric uh, field. So this is the electric discharge machine. This is just the layout, the example, what it looks like. So we can get to the next part. Next, please. Now, right. Now about the history. So electrical discharge machine in 1770, a very long time ago, an English scientist named Joseph Priestley discovered the erosion of electric sparks. Then this discovery was developed by a Russian scientist called B. Lazarenko in 1943, namely by utilizing electric sparks to create a control process for electrical machining on conductive materials, which was later known as the EDM process. Now, EDM has developed along the lathe machine, the milling machine, and the grinding machines as leading technology. EDM is renowned for its ability to create complex shapes in very hard metals such as dies machining, cutting tools, molds made of hardened steel, tungsten carbide, high speed steel or HSS, and other materials that cannot be processed by traditional methods or cannot be cut by traditional methods. Let's go. So EDM has replaced older metal cutting processes in several applications. Another factor that has led to the growth of EDM use is its ability to process thin shapes, especially in height and temper. Where EDM is capable of cutting 16 inches plus or minus, more or less 400 millimeter in height with a straightness of more or less 0.0005 inches, which in other words it's more or less 0.0125 millimeter per size. So we can see how precise it is, how it works. So these are the working principles of electrical discharge machine. Let's go ahead. Now, material removal in the form of erosion occurs due to the presence of electric sparks between the electrode or the workpiece in the electric fluid. Electric sparks occur when the voltage difference between the tool and the workpiece exceeds the breakdown voltage of the electric gap. Now, breakdown voltage depends on the closest distance between the electrode, which is the cutting tool, and the workpiece. How close they are or how far they are, that's what it depends on. The resistant characteristics of the electric fluid, the level of dirtiness in the gap between the electrode and the workpiece, and the type of electrode that is being used. Right, the components. Now, obviously, this is a system or a machine that is, the name first of all tells us that it's electrical discharge machine, so it needs electricity to work. So first of all, we have the power supply. So the power supply regulates voltage and current to ensure controlled discharge that effectively erode material without damaging the workpiece. The other things that we need is the electrodes. Now the tool electrode, which is the anode, and the workpiece electrode, which is the cathode, are crucial for generating sparks. They are often made from materials like graphite or carbon or copper. The electric fluid. It acts as an insulator, coolant, and debris removal medium during the machining process. Now, the common fluids are the ionized water or oil. Then the control unit. The control unit manages the operation of the machine, including the timing and movement of the electrodes to maintain precision. We have the servo control system. It maintains an optimal gap between the electrodes to ensure machining accuracy. So that's all, we can go ahead.
So now I will explain about how it works. Electrical discharge machining operates through a complex interplay of several components, each playing a crucial role in the process. And its core are the electrode and workpiece, positioned in close proximity within the electric fluid path. The dielectric fluid serves multiple purpose. It acts as a medium for the electrical discharge, provides cooling to prevent thermal damage, and flushes away debris generated during machining. As the power supply applies voltage between the electrode and workpiece, an electrical field is created. When the voltage reaches a critical point, the electric field ionizes, forming a conductive path or spark channel between the electrode and workpiece. This ionization, conductive path or spark channel between the electrode and workpiece, this ionization process leads to the generation of intense heat, causing the material in the workpiece to melt and vaporize. Simultaneously, the dielectric fluid rapidly flows into the spark gap, carrying away the molten material and debris, ensuring precise and controlled material removal. This intricate sparks process lies at the heart of EDM, enabling the machining of intricate shapes and hardened materials with unparalleled precision and efficiency. Next. EDM involves two electrodes, the anode and cathode, which change shape to fit the workpiece and tool respectively. The process involves supervised electrical discharge to remove material from the workpiece. The electric field increase, leading to intense heating and liquid the electric breakdown. The liquid acts as a cooling agent during machining and removes excess metal. Next. The EDM process involves several steps. The first setup, the workpiece and electrode are positioned close together in the electric field. Then electrical discharge. When a sufficient voltage is applied, it creates an electric field that ionizes the electric field, resulting in a spark discharge. Then material removal. The interest from the spark or reaching temperatures up to 12,000 degrees must or vaporize small amounts of the workpiece material. Then the last, cooling and flushing. The dielectric fluids pulls the area and flushes away eroded particles, allowing for continuous machining without sharp liquids. This cycle repeats rapidly, gradually shaping the workpiece to the desired form.
Electric discharge machining wire cut or EDM wire cut is the thermoelectric process to cut the conductive material using a series of sparks between the wire and the material. The working principle of the EDM wire cut is to give the pulsating DC current the charge between the wire and the material submerged in the dielectric fluid. When the gap between the wire and the material is small enough, the sparks is produced, heated, eroded, and create a microcrater on the material surface. The sparks occur rapidly and the microcraters being produced will cut the material in the line of the wire. This is the animation of the EDM wire cut process.
And there's types of electrical discharge machining. Number one is wire cut EDM. Wire erosion or EDM is also called wire EDM. Wire pruning spark of eroding or spark EDM. It is a popular cutting tool in the EDM machining processes that use thin wires to cut workpiece. The thin wire in wire EDM machines represent the electrode, while the ionized water is the electric field in use. The wire machines allow the unhindered rollout of wire from the automated machine fit through a spool. This is because the workpiece and the wire may impair the electrical discharge. Thus, the cut needs a new discharge channel in the cut. This method is very practical and produces positive results. Nevertheless, you must make sure the wire pass through the workpiece successfully. The result is two-dimensional cuts in the three-dimensional parts, giving identical results to the traditional CNC machining process. And then the second is hole drilling EDM. Hole drilling EDM facilitates express hole drilling, as the name implies. The electrodes present in the hole EDM take the form of a tube. This allows the easy passage of the electric fluid through the electrodes without hindrance. The small hole drilling EDM works better than most traditional drilling methods. The process cuts with a vibrating cylindrical electrode. The cylindrical electrode travels deeper into the workpiece material while removing the substance. Chopper or graphite mixed up the electrode spray EDM of the electrode. Highly conductive and hard material such as hardened steel, composite, and titanium are processed using EDM machines. Unlike the traditional drilling procedures, the hole drilling EDM process makes perfectly tiny and deep holes. It employs the same basic principles present in the die sinking EDM process. In this case, no matter the degree of hardness of the of metal involved, there is no need for deburring. And then the last sinker EDM. This EDM type is also known as RAM EDM, cavity type EDM, volume EDM, or die-sink EDM. It is called conventional EDM because it is one of the earliest EDM process. It came from complex cavity shapes for several casing applications. Thus, the name PT-type EDM. This method is called single EDM because it can produce complex geometries or shapes. Using pre-machined chopper or graphite electrode, this process forms a positive of the desired shape. Pressing the electrode into the workpiece to create a negative of the original material shapes makes the electrode sinks into metals to create complex 3D shapes, patterns, and holes. However, some components are likely to affect the electrode material in this EDM operation. Therefore, you have to take note of the electrode's conductivity and its opposition to erosion.
Then we talk about the advantage of EDM. The first advantage mentioned here was the greater design freedom. EDM allows manufacturers to cut shapes and depth that may be impossible for the traditional manufacturing process. These cuts include perfectly square internal corners and undercuts, creating parts within thin walls, and also where EDM easily cuts thin slots in extrusion dies better than conventional methods. Micro EDM is the best option when cutting internal corners with very small radials. This technique has a unique capability of creating an inside corner in CNC machining. In addition, many manufacturers rely on this technique to produce non-round opening and cavities in their workpiece. Meanwhile, engineers can create blind and high aspect ratio pocket with single EDM. The next advantage is distortion-free machining. The tools involved in electric discharge machining do not directly come to contact with the workpiece at any point. Hence, the workpiece does not suffer from any deformation or disfiguration in the process. This is because there are no force applied to the material. This allows easy machining of fragile parts without of the fear of making it parts. In addition, this absence of distortion in this process is meant to achieve a very tight tolerance, about of plus minus 0.012 mm. High quality surface finish. EDM creates surface with a high precision and smooth finish. Most manufacturers often subscribe to applying this method as an injection molding surface finish. It provides more excellent results than other common traditional surface finish process. Precision. Even though the EDM has limited efficiency in manufacturing large orders, the EDM is an ideal method for manufacturing small parts and prototype because of its outstanding precision. And also EDM has excellent application level in automotive industry and aerospace industry. This is because it can deliver high measurement accuracy levels to create complex engine components. Work on hard material. Most conventional machining method needs to be applied before solidifying the workpiece. Rigid materials like tungsten carbide, iron cell, and hardened steel may not be easily to machine. On the other hand, EDM is a method compatible with hard materials. This is one of the essential benefits of EDM methods. It works well with any material available, material with a great conductivity. In addition, it also prevents any possible deformation from the heat application. And after the advantage, we talk about the limitation of the EDMs. Can only machine conductive materials. This is crucial because EDM can only process with the conductive materials that can the electric can throw the workpiece into the tool into the workpiece, and then slow rate of material removal. The material removal rate in EDM machine is pretty slow, unlike the conventional machine process. The machining process is undoubtedly a high intensity method. This means that it takes a longer time. As a result, increase in manufacturing time affects the overall cost. Therefore, EDM is not an efficient application process when it comes to large-scale projects. More expensive. The EDM method is more expensive than conventional milling because of its high electricity demand. It creates an extreme carbon footprint, making it less environmentally friendly. Many companies worldwide aim to provide adequate measures to reduce carbon footprints and introduce other methods that demand less electricity. Difficult in reproducing sharp corners in the workpiece. Since EDM manufacture depends on electricity and heat to remove the metals, the electrode become worn out. Consequently, this affects the electrode wear, mainly deposit in a workpiece, sharp, corner, or low surface. The reproducing accuracy of the electrode will be affected negatively. So there's a will the tool is worn out, this will directly change to maintain this limitation, the difficult in reproducing sharp corner on the workpiece. I think that's all from the electric discard mentioning from us. If there are any mistake, any less information, or mistake information, we say sorry. But I hope the viewer will know about EDM process better than before. Thank you.
And thank you for your attention. And I think this brings us to the end of our presentation. And if there's any mistakes or any less information, just like my friend said before, we apologize. But I think if it's your first time seeing this, I think you have more information than before now. So we apologize for any less information or any mistakes made in the process. And this brings us to the end. And thank you all.